In this video, I'm going to solve this compound inequality. Negative 5x minus 7 is less than 13, and 2x plus 5 is less than 15. And when we're solving compound inequalities, the first thing we want to key up on is this word, and, or. But in this case, we have and. What does that mean? And indicates the intersection between the two. And the symbol for intersection is this. Just in case you don't know, it's like an arch. So that's the intersection. So we want to know, where do these two inequalities overlap? Where does the solution of these two inequalities overlap? So a little side example here, just real fast. If I had x was greater than 3 and x was less than 5. Let's just pretend like that was my two solutions. What we'd be looking for is all the values greater than 3 and all the values less than 5. So that would fall between 3 and 5 because that's where it would overlap. That's where all the common ground between all the numbers greater than 3 and all the numbers less than 5 meets. Just right between 3 and 5. That's what we're looking for. But in this problem, we have a little bit more of a complicated scenario because we have this equation, or not equation, but inequality, and another inequality that we need to solve, and then we determine what the solutions are to that inequality, and then we put it all together. So let's go ahead and solve each one. In the first one, negative 5x minus 7 is less than 13. I'm going to add 7 over to both sides. Solving inequality is just the same as solving an equation. You just have to be careful with the inequality sign. So I have negative 5x is less than 20. And here's what I mean, you got to be careful. I'm dividing now by negative 5. When I am dividing inequality by a negative, moving that negative across, I have to flip the inequality. So this is going to become x is greater than 20 divided by negative 5 is negative 4. That is something that really easy to forget about that. And just, if you forget about that one little rule where you have to flip that inequality when you're dividing by a negative, you're going to mess up a lot of things. One note I do want to make, let's say I have like 2x is less than negative 4 like this, and I divide by 2. In this scenario that I just drew in, this scenario, you do not need to flip the inequality because it's just negative 4 divided by 2. I'm not dividing by a negative. I'm not moving a negative across that inequality, so I don't have to worry about the sign. So in this one, I do not flip. But in this one, I do. I have to flip that inequality. So one little note I wanted to make there, just so we know the differences of when we are flipping and when we're not going to flip that inequality. So again, I divide by negative 5. It was less than, it turns to greater than. So x is greater than negative 4. Now we just have to solve this other inequality. I'm going to subtract 5 from both sides, leaving me with 2x is less than 10. 15 minus 5 is 10. I'm going to divide by 2. X is less than 5. All right, so I have two inequalities now. I have one saying x, all the solutions of x greater than negative 4, and then the other one is all the solutions less than 5. Most questions will ask to graph. And when they ask you to graph, what they're really asking you to do is draw a number line. Really good straight line right there. No assistance. So the two numbers I'm looking at is negative 4 and positive 5. All the numbers greater than negative 4 are going to be this way. All the numbers greater than negative 4 are going to be this way. And I'm going to use a parentheses there. So it's strictly greater than. Then I want all the numbers less than 5. So I'm going to go out this way. Less than 5. And that's going to be an open parentheses. So what we're wondering is, where do these two solution sets overlap? Because we have the word and. And means overlap. And means we want both things to happen. This and that. Both things. So the overlap is going to be in this zone right here. I knew that was going to happen. There it goes. All those numbers between negative 4 and 5 is going to be our solution. So this is the graph, technically. This is the graph. Some questions also might ask for interval notation also, which I'd be willing to bet that it's going to ask for a graph. It's going to be asked for interval notation. In interval notation, we just write the solution set. So this is going to be from negative 4 with the parentheses, because we have strictly greater than, to 5 with a parentheses, because we have strictly less than. If we had less than or equal to, or greater than or equal to, we would use brackets. But here, we have strictly less than, strictly greater than, so we use parentheses. So So -4 to 5 is going to be our interval notation of the solution. So compound inequalities, pretty fun. Just gotta know this word here, and. It's and, what are we looking for? It's or, what are we looking for? Or, let's just pretend we're talking about or it could be any potential solution. So, if you want to see that, let's just pretend. So let's say x is greater than -4, or x is less than 5. Let's say the question was asking or. So we have our line here. I'm just going to refer back to this line right here. So these are all the solutions. X is greater than -4. X is less than 5. When we're talking about the word or, it could be anything. This or that. This could happen or that could happen. So it could be any potential highlighting space that we have. I highlighted the entire number line. I highlighted from -infinity all the way through +infinity. So my solution, there's the graph. I already graphed this solution. But now putting in an interval notation this time with the word or, the solution here is going to be from -infinity to +infinity when the word is or. The original question was asking and. I'm just throwing in this or scenario just in case you're like, well, what is or? What would that look like? Here it is. It would be from -infinity to infinity. And my infinity sign is not very good. That's not any better. Let's try one more time with this one. All right. Not very good, but you get the idea. Those are infinity signs. And technically, if I go back just real fast to the and, in your final graph, you would only want to graph this portion from here to here. Like, you wouldn't want this extra highlighting. If you did do this, see how I like made a little bit darker in that middle part? Me as the teacher, I'm fine with that. Like, if my student submits this, like, hey, I darkened in the actual solution set, I'm fine with that. I don't need to see a whole separate line. Just know what your teacher's looking for there. But for me, I'm not going to care about that. So hopefully this helps you out with and then I threw it in a little bit of an or there. A little bit of extra lesson there. So hopefully this helps.